The wastewater enters the clarifier, the speed of the incoming water is slowed, and the water evenly distributes around the tank. The point is to introduce the wastewater into the clarifier as quietly as possible. The higher the flow rate, the greater the turbidity, and the greater the solids flowing over the effluent weir, rather than settling out as solids. Most sedimentation basins have 4 zones. The influent or inlet zone decreases the velocity of the incoming water and distributes the flow evenly across the basin. The settling zone provides the calm area necessary for the suspended material to settle. The effluent zone provides a smooth transition from the settling zone to the effluent flow area. It's important that currents don't stir up any settled solids and carry them into this area. The final zone is the sludge zone, where settled solids are separated from other particles in the settling zone. There are many variations in design for sedimentation basins. The 2 most common types are rectangular and circular clarifiers. In a rectangular clarifier, water flows across a rectangular basin. A circular sedimentation basin is fed from the center, and water flows to the outer edge of the basin. There are many alternatives to traditional sedimentation, including high-rate and upflow clarifiers. These variations in design are generally used to reduce detention time, increase flow rates, and raise capacity within a smaller footprint. All clarifiers use weirs and water overflow to separate the less turbid water. A weir is like a small dam, gate, notch, or other barrier placed across a basin to help regulate water out of a basin. The weir overflow rate is used to determine the velocity of wastewater over the weir. The velocity informs the operator about the efficiency of the sedimentation process. At constant wastewater flow, the shorter the length of the weir, the faster the water velocity will be out of the basin. Conversely, the longer the weir length, the slower the velocity will be out of the basin. The goal is to remove the majority of total solids from the water, even if that means multiple clarifiers or recycling the water back through the clarifier more than once. Once that is accomplished, liquids flow one path and the sludge another. Sludge can be removed at intervals or continually removed by mechanical scrapers installed to scrape the sludge away. The solids removed from the bottom of the clarifier or sedimentation tank are called primary solids. These solids are further handled at the plant through dissolved air flotation, digestion, and disposal. The sludge can be placed in lagoons or on sand beds where it eventually dries out. It can be dried by mechanical dewatering techniques. It can be sent to a treatment plant for processing. Attention must be paid to how long the flow remains in the basin. Too long, it goes septic. Too short, inadequate removals. This solid-liquid separation process removes upwards of 90 to 95% of settleable solids, 40 to 60% total suspended solids, and 25 to 35% BOD5